I run a 5-node Kubernetes cluster in my basement. This line on your resume will make you stand out from 99% of DevOps job seekers. And in this video, I'm going to show you how to build a Kubernetes Homelab from scratch. The first thing we're going to talk about is hardware. I don't recommend using virtual machines. I recommend using bare metal devices. And the reason for this is that virtualization adds an extra layer of abstraction to your learning that you might not be interested in if your goal is to learn Kubernetes. Because Kubernetes is the tool to focus on if your goal is to land a DevOps job. So I recommend getting as close to the source as possible, basically. And you do that by running bare metal devices. Also, there is something about actually seeing the device, like I have behind me here. There's something about actually seeing the device, and if you run an application, knowing that it's actually running on that device rather than on an abstraction on that device, it's something you have to experience for yourself, but there's something really satisfying about that. Now, you don't need a huge rack, you don't need fancy RGB lighting, you don't need these huge setups that you see in other people's YouTube videos. I am 5 years into my career now, and this little rack is the first rack that I've bought. So far, I've only been using old refurbished hardware. So in this video, we're going to be using 2 Raspberry Pis, but you don't need to use Raspberry Pis. I'm just doing that because I have them lying around and I want to start using them. But up until this point, I have used old laptops or old refurbished enterprise hardware for my home labbing. You can really literally get started with an old laptop you have lying around. So don't take the hardware requirements as something you have to have. There's a recent trend happening with mini home lab racks, and that really spoke to me because I live in a small apartment and I'm also very sensitive to noise. So I can't really have a huge rack with enterprise grade rack mounted servers in there because they are noisy and they take up a lot of space. So I really like this idea of doing a mini rack. So I bought some hardware and I already had the Pis lying around, so it was a good match. And that's why I went for it. In this video, I'm going to be using 2 Raspberry Pi 5s, one of 8 GB and one of 4 GB. And I mounted them in a GeekPi 10-inch rack with 8 units. I also got the rack mount for Raspberry Pi 5, which holds 2 Raspberry Pis. And I really like this mount because it shows 2 HDMI ports that I can just easily access from the outside if I need to. And it just looks really clean with the LED lights and such. You can get the full parts list and hardware specification by downloading the full written Homelab guide from the description below. So now that we have covered hardware, let's dig in. I'm using 2 SD cards. So each of these Pis, the rack is holding 2 Pis, and each of them has an 64 GB SD card. And I just used the Raspberry Pi imager to flash those. I used the Raspbian OS, so the one that you get with the graphical environment. And in terms of settings, all I've done is set a password and give them a public SSH key. I haven't done any other settings because you get that when you do the imager. You get some settings that you can do and apply that right away into the Pi. All I did was add my user, password, and a public SSH key, nothing else. So these devices are now on my network with the following IP addresses, 10.39 and 10.60, and I gave them an alias in my etc hosts file. So what I can do now is SSH Misha at Pi1. Then this is going to prompt me for my SSH key, and now I am SSH'd into it. So my Pi1 has free SH. The Pi1 has 7.9 GB of RAM, and if I split this, let's do a horizontal split, SSH Misha at Pi2, yes, and now I'm SSH'd into the second Pi, and this one has 4 GB of RAM, as we see. So when I was preparing for this video, I was actually mapping out all of the steps and thinking of doing a pretty polished video. But actually, I think there's more value if you see my thinking process as I'm going along with this video, as I'm actually building it. And I figured I'm just going to do this off the cuff. I'm going to make a bunch of mistakes along the way. I'm gonna need to do some debugging. I think that's actually much more valuable rather than just giving you a list of steps. Now, I have done this thing many times before. I know what to do, but I'm still going to show you the process. It has been a while since I've set up a K3s cluster, so I figured I would just approach it that way. So we're gonna be setting up a Kubernetes cluster, and we're going to be using K3s for that. Now, there's a couple of reasons why I always recommend K3s to my students, at least in the beginning. The first reason is don't start with kubeadm because it's too intimidating if you're a beginner, and it's just going to lead to frustration, and you're not going to get this, ooh, I'm learning something, this feeling of early mastery. You're not going to get that, and it's really important to get some positive reinforcement early in your learning process. So don't start there. You can move to that when you are a bit more advanced. And the thing that I am actually using in my home lab is Talos. But again, I don't recommend going into Talos Linux as a beginner because it's much more valuable to actually have access to your Linux OS. So Talos actually takes over your entire disk and it only exposes an API. You can't even SSH into Talos, which is why it's great because it's completely secure. But if you use K3s, you still keep your Linux operating system. I'm running Raspbian OS on these Pis now, and after my Kubernetes cluster is set up, I can still tinker with Linux. There are still things I can do on that Pi besides running a Kubernetes cluster. So that's the reason why we choose K3s. Finally, K3s is great because it's easy to set up, it works out of the box, and it runs as a single binary, which is amazing. Now we can get started. I have my both Pis set up, and all I did was just install the image, and that's it. Now I'm SSH'd into them. But the first thing that we need to do is to set the host name, because as you see here, both of my Pis have the same host name, and that is always a bad idea. So this is my Pi 2, so sudo, I'm going to change that with sudo systemctl, sudo hostname ctl set hostname Pi2. And if I now run hostname, it's Pi2. If I here write hostname, you see it's still Raspberry Pi. So sudo hostname ctl set hostname Pi1. So now we have set our host names. That's always a good practice to do. And you see that my Pi is still called Raspberry Pi, but if I would exit this session and then SSH back into it, then we see that the host name is now changed in the prompt. So it's just a prompt thing here. So I've changed my host name. This is all working well. And then now the next step is to just go through search for K3s and open up the K3s documentation. And literally, this is how easy it is to install K3s. We're just going to curl this installation script. And that is going to download the binaries and set everything up for us that we need to set up. And we errored out. So it is already showing us why it errored out. Here is the info line here. It says, you may need to add cgroup memory 1 and enable memory if you are using a Raspberry Pi. So that's very convenient. So let's check out what this boot command line txt is all about. Do not edit this file. Okay. So apparently on the Pi it has moved. So let's open that and see what it's like. Oh, and right away I see that it's opened as read-only. So it would not make sense to make any changes here because I will need to edit this as root. So I'm just going to do sudo like that. That's going to rerun the same command. And it wants me to add here cgroup memory and cgroup enable memory to it. So let's just do that then. Cgroup memory and cgroup enable memory, like that. Let's also do the same on the other Pi. And actually, let's just reboot this. But before I do it, I still see this unable to resolve host Pi1. And I think that might be yeah, this is probably the reason. This is still set to Raspberry Pi. So let's set this to Pi 1, like that. Like that, yeah. And now I will reboot this one. And you should see in the back, yeah, now the light has gone off. So that's actually pretty cool to see. So this one is now closed. We can do the same on this one. So we're going to open the command line file. And here I'm also going to add cgroup enable memory like this. And I'm also going to edit the etc hosts file and change this to Pi 2, like that. And let's reboot that as well. So if I now go back to Pi 1, hostname is set up properly. And now we can try running the script again. It's still in my history, so I'm just rerunning the same command. And now we see that our K3s has started. So let's see. Sudo, I know that I can just try kubectl get nodes. We see that the etc rancher k3s.yaml, that is actually set with root permissions. So let's do sudo kubectl get nodes. And here we go. We see that we have a node called Pi1, which is a control plane. Awesome. So now we can see how our second Pi is going. This one is working too. Our host name is set up properly. And then we can add this one as a node in the same cluster. So now we have the control plane running here, but we want to configure this one as a node in the same cluster. And let's see, in the documentation, in the quick start guide, it shows you to install additional agent nodes and add them to the cluster, run the script with a couple of parameters. So then we need to get the IP and we need to get the token. The value of the token is stored at varlib rancher node token on the server node. So let's check that out. Cat. Run it as root. There we go. Here's our token. And our IP address is going to be the IP address of this node, of the control plane. Now, I can figure that out by running IPA. And I know it by heart, but here it is. The IP address is this. So we need the IP address and the token. Now we have everything we need. So we can copy this command like that. And I'm just going to run set-ovi, because then I can navigate here with vim key bindings. And here the location of the API server of the control plane is going to be the IP address of Pi1, so 192.168.10.39. And the standard port for the Kubernetes API server is 6443. And then the token is going to be the value of this, like that. Paste that in. And now, no, I lost it. Okay. Do it again. Actually, sometimes I like to just v command txt. I actually like to paste that in like that. So now I can take this value. $39. And the token is going to be this. Okay, so this is the entire command. And if I then just take that, here we go, here's our full command. So curl 192.168.10.39. This is the control plane. This is the port where the API server is running with our token, like that. This should work. Now it's downloading the binaries. Starting K3 as agent. And it's finished. So now, if I run the get nodes command again, here we go. We see that we have a 2-node Kubernetes cluster running right in that little cabinet behind me, and we can start going. That's how easy it is to get a Kubernetes Homelab going if you know what you're doing. So if all of this command line work, if that went a little bit fast for you, then I understand. And this is also why I always recommend learning Linux deeply first before moving to containers and Kubernetes. If you watch this and you were not really able to follow what I was doing, that's a clear indicator that you're not ready for a Kubernetes Homelab yet. In that case, you should focus on Linux first. And this is also what I teach in KubeCraft, where we are landing DevOps jobs every single week now, with Brad landing an SRE role, Frederick landing a role, Jakub, Peter, Leonard, he landed a job in 2 weeks. And they do that because they follow my system, where we first go deep into learning Linux with Arch Linux, etc. That is an 8-hour course. Then there is an 8-hour Kubernetes fundamentals course. And then, and only then, do we move on to the Kubernetes Homelab course. So now we have Kubernetes running, and that is great. But to actually understand what we're doing here and to build a secure Homelab, that is a bit of a bigger undertaking, which goes beyond the scope of a short YouTube video like I'm making now. If you feel that this went a little bit fast for you and you want to have a slower approach with more hand-holding and actually like deeply going into each step along the way, then I recommend you apply down below for my program, where you get direct mentorship from me and where you get access to my courses. Take the same process, but then spend like 16 hours explaining everything that we have just done. So apply if that sounds interesting to you. So let's move on. We now have a Kubernetes cluster running. Now we can actually start running some applications on there. And one application that I love to do is Linkding. Now, before I start applying this, I do not want to just keep doing sudo kubectl on the Raspberry Pi. We're going to do something a little bit more mature, and we are going to set up a environment from the local machine. I'm not going to run kubectl from the actual servers. That is not how you usually manage Kubernetes clusters. No, these servers are servers. The control plane exposes an API, and that means I can talk to the API from my local machine. So what I'm going to do is, first of all, like I'm a pretty advanced user of this. So if you run which kubectl on my system, you will see that I don't have kubectl installed. I work completely from dev containers. And I'm just going to quickly set up a dev container for this project. So I'm going to first run the template command. This sets up a template called general, which contains a dev container, JSON, etc. And I'm going to move general to PyLab vid, like this. And then I'm going to cd into that, and I'm going to run devpod up. Devpod up dot. Now what this is going to do is it's going to create a dev container, which is a completely isolated environment running on my local machine here. This is going to automatically install all sorts of packages that I have defined. Let me just accept my SSH key here. It's going to clone all of my dot files. It's going to set up my complete dev environment with all of the things that I want to have in that environment. So now it's set up. I run devpod ssh, and then I can go into the PyLab vid. Now I have a full separate environment, completely separate from my host system. And here I can then install kubectl, means use kubectl. This is going to install kubectl. And I have a completely tailored dev environment with all of my Vim configuration, everything loaded in already. Now I have kubectl available, but now we need to get the kubeconfig file, right? Because if I run kubectl get pods now, it's not going to find anything because we don't have any kubeconfig. So if I then go to one of my nodes, and what was it? cd etc rancher, k3s, sudo cat k3s.yaml. Yeah, here we go. This is the kubeconfig file. So I'm just literally going to take this and copy my kubeconfig file. And if I then open v home directory cd dot, wasn't it dot cube? Or maybe I have to make it. So I go to my home directory, I make a directory called cube. In there, I'm going to create a file called config. And now it's actually going to install LazyVim for me and set up everything that I need in order to do my text editing. And then I just paste in the kubeconfig file. And there's one thing that we need to change, namely the location of the server. Because on the Raspberry Pi, it's configured to look at localhost. However, we know that our IP address is actually 192.168.10.39. That is the location of the control plane on my network. So now if I run kget nodes, actually I have to go back into my workspace here. Now I run kget nodes and here we go. Now I'm able to talk to my Kubernetes cluster from my isolated dev container. So again, to show you how this works, if I do which kubectl, I see that in this environment, I have kubectl installed. This is running on my Arch Linux system, but if I do which kubectl like this, I have no kubectl on my host system installed. That's because this is running in a dev container, and now I can create a tailored environment for my Raspberry Pi Homelab containing all of the packages and code and everything that I want to use for that Homelab. And this is very advanced, but it's also part of the stuff that I teach in KubeCraft. There's a full course on how to actually install this and how to do this. So if you want to learn that, check out the link below. So now that we have everything set up, I can talk to my Kubernetes cluster from my local machine with all of the tools that I want. So now I'm going to actually run an application. So the first thing that we're going to do is we're going to run Linkding. So if I do the dep.yaml like this. Okay, so this is a YAML file. Here we are going to create a namespace called Linkding, and we're going to create a deployment that's called Linkding with one replica. And the image that we're pulling in is sysbroker Linkding 139. And we're going to run this on port 1990. Now this application, this is called Linkding, and it's a bookmark manager. So if you do Linkding, it's going to first show you, yeah, here we go. This is the GitHub repo. We're actually at version 142 now, so maybe I should change that, but it's an open source project and it's a really nice little example application to run. So if I run this, okay, apply f dep.yaml. It has created the deployment. So if I do kget pods now, then we see that we have Linkding being created. But actually, I realize now, because I'm doing kget pods, it's actually doing that from the names. Yeah, it's doing that from the default namespace. Actually, I need to set namespace here to Linkding as well. That's a bit of a mistake, but hey, that's how it goes. Kget pods, it is still creating. So let's give that a few seconds. So let's check on our pod, kget pods, And here we go. We see that our pod is now running. So now I can actually do a port forward to see if we can actually log into our Linkding application. So I have the example command here. So I'm going to make a small adjustment here. I'm actually going to run this on 1990 on my local machine. Like that. So if I now run port forward, and then I have to complete the name. So now I'm port forwarding to the pod. And if I now run localhost 9090, I should see my login page. Here we go. Here is our Linkding login page. And this is actually running on the machine behind me here. Great. So now we have a interface, but now we also need to be able to actually log into it. And that means that we have to run a command that is going to create a super user for us. So this is the command. And we're going to have to adjust that a little bit. So I'm going to just SSH, like I now have the port forward command open in this dev container, but I can just SSH into a new one or have another session to that container, and I can just do more sessions into that. And if I paste this command and replace this with the actual one, it is throwing an error, but let's see if it actually worked. Let me see. No, it doesn't. It does not. Okay, it looks like we have to upgrade to Linkding. Okay, so it looks like we have to upgrade to the latest version after all, because it's throwing errors. So then the first solution is just to upgrade to the latest version. So I'm just going to delete the deployment of LinkedIn. Then we're going to check our YAML file again. And I already updated the namespace here. But now we saw that the latest version is 42.0. I believe that was it. Yes, 42.0. So let's then apply that. Okay, so the deployment is running. Okay, config set context namespace is Linkding. Oh, set context default namespace Linkding, like that. So now we are doing everything in the Linkding namespace. Okay, got pods. Okay, Linkding is running now. So let's see if we can run that create super user command again. Okay, now it is asking for my password. So let's just do password. I want to create it anyway. So now my super user is created successfully. And let's go to localhost 9090 again, which won't work because our port forward is lost because I have created a new pod. So let's try that again. Now we are forwarding again. And here we go. Here is our LinkedIn. And if I now do Misha and then password, we are actually able to log into the application and it works. Now, this is great. We have it working. There's just one thing that we still need to do, and that is to make sure that we can actually log in without using port forwarding. And for that, we're going to create a service. Now, the great thing, and also why I recommend using K3s, is that this has something called ServiceLB configured out of the box. So what we're going to do is I'm going to create a svc.yaml file. And this is going to be a service which we are going to deploy in the Linkding namespace. This is a load balancer type service, which is going to target the app Linkding, which is defined in our deployment file, with port 9090 and the target port 9090. So if I apply this file, oops, spelling mistake. API version not set. That is something that got lost in the copy paste. Okay, now the service Linkding is created. So if I now do kget svc, now we see that we have a load balancer service, but note it has an external IP, and this is very important. If you have ever tried to create a Kubernetes cluster before, you will know that usually this is going to lead to problems, that you won't get an external IP. However, K3s does this out of the box, and this is super neat. So now if I just enter the IP address of the actual Raspberry Pi here, and port 9090, now I'm actually able to log in on an IP address. And now I could, for example, in my Homelab dashboard, I can actually now point this to a service that's running on my Kubernetes cluster behind me. And that is one of the reasons why K3s is such a great option, because you can actually just create load balancer servers so that you can run applications on specified ports on your Raspberry Pi. It works great. Well, there you have it. Now you have a Kubernetes Homelab where you can start building, experimenting, and start learning the tools of the trade of a DevOps engineer. This is just the beginning. We haven't even touched on exposing your applications to the internet yet, security, persistent storage, etc. All of that is done in the Kubernetes Homelab course that I used for my students to land six-figure jobs. And you see it works. We are landing jobs almost every single week. And as people say, Leonard here, he does this because he created a K3s Homelab. Another example is Daniil, who landed a DevOps job straight out of university and talking about his Homelab and all the little projects that he learned in KubeCraft was the biggest part of his interview process, and he barely even got any other technical questions. So this stuff really works. If you just want to get going, get the full system, plug and play, and get started right away, including direct mentorship from me, where you can ask me in the community questions if you get stuck on anything. Click the link down below and you can apply and see if we are a good fit. All the best of luck with your new Kubernetes Homelab. Thank you so much for watching, and I'll see you in the next video.